All right, fellas, we are continuing to lesson 8.3 today. I know we're doing a lot, but as you may know, we don't see each other as much as possible as we did before. So we got to do more within each lesson, within each day that I see you. Okay, so we're moving on to 8.3. So by now you were doing some standard form and general form of an equation of a circle with the radius and all that stuff. Now we're going to talk about some lines and some angles that are made inside of a circle. Okay, so first we need to start with some definitions. And the first definition is a chord. Okay, a chord is a line segment that joins 2 points on the circle. Okay, so its endpoints are on the circumference. It's a segment which has its endpoints on the circumference. Okay. An arc is a curved section of the circumference which has 2 endpoints also on the circumference. Okay. Now, an angle, we're going to have some angles now. If I draw in this angle, let me call this angle here. Okay. This angle at the center. When we have an angle at the center, this is called a central angle. Very, very important. People get these confused with other angles. So you got to make sure you know which ones are the central angles. It has a vertex that is what? What is the vertex? The vertex is the center, and the sides are, what are the sides? What are these called of the circle? These are the radii. Plural for radius is radii. Okay, now here we're not just talking about the radius length, we're talking about the actual segment that is the radius, which goes from the center to the circumference. These are the 2 radii that make that central angle. Okay. In this diagram, when we draw this in, right, the measure of, let me call this angle C. The measure of angle C will be equal to the measure of arc PQ. Okay, so the measure of the arc is also in degrees. Okay, and so the central angle is equal to the measure of, we put usually a little m there to denote the measure of the arc PQ. Okay, and we have to use the arc symbol here, because if I just said PQ, people would get that mixed up with what? That would be the length or the distance from point P to point Q. That would be the length of the arc PQ. So we've got to use that curved arc above PQ. Okay. An inscribed angle, let me draw an inscribed angle. An inscribed angle goes something like this. Let me call this angle T. Where is its vertex? Okay. Its vertex is on the circumference, or on the circle itself. And its sides are what? What do you know about its sides? So its vertex is on the circle and its sides are chords of the circle. Okay. Now the measure of angle T is half the measure of the arc PQ. Okay. The measure of the inscribed angle is half of its intercepted arc. We call this the intercepted arc, okay? This is what I just highlighted. So that arc has been intercepted by both this central angle and by this inscribed angle, okay? So it also happens to be half of the measure of angle C, right? So the inscribed angle is half of, and you can almost kind of see this, right? This angle in here is half of this angle in here, okay? So don't get those confused. They're not equal, right? One's definitely smaller. You can tell that that red angle is smaller than that blue angle, okay? So let's look here at example 1, okay? Example 1, we have this marked as angle X. Is that a central or inscribed angle? That is a central angle because it's at the center. And remember, it is the same as the measure of the arc. And the measure of the arc was shown here to be 35 degrees, so X has to be 35 degrees. It's very easy, okay? But of course, it gets harder. This angle here is an inscribed angle. It has cut off an arc that's 44. So X is 1/2 the measure of arc AC, not equal to. So it's going to be half of 44. So X is 22 here. Okay. What about number 3? Well, so we've got a central angle here, right? And we know that it's equal to this arc up here, so that's X. But that's going to be double the inscribed angle, right? 75 has to be half of X. So if you do some algebra there, multiply by 2 on both sides, right? Multiply by 2. The half and the 2 cancel, and you get X is 150. And last but not least, an inscribed angle right here is half of its intercepted arc, but we don't know the arc, but we know its central angle is 86, which is the same as the intercepted arc. So X has to be 1/2 of 86, so X is 43 degrees. Okay. I'm going to leave the last one to do in the Google Meet. See you there.